Space is an endless ocean of darkness, and we are only floating on its surface. We often gaze at the stars with wonder, but the cosmos holds secrets far more terrifying than beautiful. This journey will reveal 30 facts about space that will challenge everything you think you know about safety and reality. You will discover the dark and mysterious forces that govern our universe, leaving you with a profound sense of awe and a touch of primal fear. What cosmic truth are you most afraid to learn? Our first terrifying truth begins with the very air we breathe, or rather, the complete and utter lack of it. The vacuum of space is an environment of pure hostility, a silent killer that would dismantle the human body in moments. Without the protective embrace of a spacesuit, exposure is a brutal and swift end. The absence of external pressure would cause the fluids in your body to instantly begin to boil, a gruesome process known as ebullition. Your saliva, the tears on your cheeks, and the very blood in your veins would start to fizz like a bottle of soda suddenly uncapped. Your body would swell to nearly twice its normal size, trapped within a skin that struggles to contain the chaos inside. At the same time, the air in your lungs would rush out in a violent, explosive decompression, collapsing your airways in a fraction of a second. You would not explode, but you would be left contorted and frozen, a permanent sculpture adrift in an infinite, airless grave. This is not the quiet, peaceful drift often shown in films. It is a physics-driven nightmare, a reminder that our existence is a fragile bubble and space is waiting to pop it. That silent, airless death is a personal horror, but an even greater terror looms over our entire world, a fate written in the very star that gives us life. Our sun, the steady anchor of our solar system, is slowly burning itself out. It is a massive, ongoing nuclear reaction, fusing hydrogen into helium in its core. For billions of years, this process has provided the light and heat that makes our existence possible, but this fuel is not infinite. In about 5 billion years, the sun will exhaust the hydrogen in its core. This is when our star will begin its death throes. As it runs out of its primary fuel, the sun will start to burn helium instead, causing its outer layers to expand at an unimaginable rate. It will swell into a monstrous red giant, a bloated inferno that will engulf the inner planets of our solar system. Mercury will be the first to vanish, swallowed whole and vaporized in an instant. Venus will follow, its thick atmosphere offering no protection against the stellar furnace. Then, the expanding edge of the sun will reach Earth. The oceans will boil away into space, the rock of the crust will melt into magma, and our entire world will be consumed, reduced to nothing more than a whisper of superheated gas within the star's atmosphere. This is not a speculative disaster or a potential threat. It is an astronomical certainty, a scheduled demolition of our planetary home set on a cosmic clock. Long after humanity is gone, the sun will finally shrink down into a cold, dense white dwarf, leaving behind a ghost of a solar system, dark and frozen for eternity. Our world has an expiration date, and it is signed by the sun itself. While our sun's fate is sealed in the distant future, a more immediate and invisible predator might already be hunting in the darkness between the stars. Rogue black holes are the ultimate cosmic phantoms, stellar mass monsters that have been flung from their birthplace to wander the galaxy alone. Unlike the supermassive black holes that sit at the center of galaxies, these drift silently and unseen through the void. Their incredible density means a single one could contain the mass of 20 suns compressed into a point smaller than a city. You could be looking straight at one through the most powerful telescope and see absolutely nothing, a perfect circle of emptiness against the starfield. It is this invisibility that makes them so terrifying. A rogue black hole would not announce its arrival with a blazing trail of light. It would simply be there, its immense gravity warping space itself as it moved. If one were to drift undetected into the outer reaches of our solar system, the delicate gravitational ballet that holds our planets in their stable orbits would be thrown into chaos. Its pull would be like an unseen hand yanking on the strings of a mobile. The outer gas giants Jupiter and Saturn would be the first to have their paths violently altered, sending them careening on new, unpredictable trajectories. This disruption would ripple inward, a gravitational shockwave that would destabilize Earth's own orbit. Our planet could be flung out into the frozen depths of interstellar space or sent spiraling toward the inner solar system. And if any object, a planet, a moon, or even a star, ventured too close to the black hole's event horizon, it would be subjected to a process called spaghettification. The force of gravity on the side closest to the black hole would be so much stronger than the force on the far side that the entire object would be stretched out into a long, thin stream of superheated plasma, like a piece of cosmic taffy, before being consumed entirely. The true horror is that we might not know one is coming until it is already too late, a silent ghost in the galactic graveyard on a collision course with our home. Yet even a phantom black hole gives us a fighting chance, a slow and detectable disruption. But the universe has a weapon of instantaneous annihilation, a flash of light so powerful it could erase life from across the galaxy without a single moment of warning. Gamma-ray bursts are the most violent explosions known to exist, second only to the Big Bang itself. They are the final death screams of massive stars collapsing into black holes, or the catastrophic mergers of ultra-dense stellar corpses like neutron stars. In a fraction of a second, these events can release more energy than our Sun will emit over its entire 10 billion-year lifetime. All of that incomprehensible power is focused into two narrow, opposing beams of high-energy radiation, firing from the poles of the dying star like a cosmic laser. If one of these beams were to be pointed directly at Earth from within our own galaxy, the consequences would be immediate and absolute. There would be no alarm, no time to react. One moment, the night sky would appear normal. The next, a second sun would appear, blindingly bright in gamma rays, invisible yet utterly lethal. This flash, lasting only seconds to a few minutes, would deliver a radiation dose powerful enough to scramble the DNA of every living thing on the planet's surface. The upper atmosphere would be transformed into a toxic soup of nitrogen oxides, chemically shredding the ozone layer that protects us from the sun's ultraviolet light. The sky would then literally fall, as the devastated ozone layer allowed a flood of ultraviolet radiation to pour through, scorching the planet and wiping out the base of the food web through a process called photoplankton mass extinction. The initial burst would be over before you could even finish a thought, but the long, slow death of our biosphere would have already begun, a silent, invisible poisoning from the heavens. We are essentially living in a cosmic shooting gallery, hoping that no dying star in our galactic neighborhood happens to have its gun aimed at us. The universe aims its most destructive weapons directly at us, but our galaxy is already caught in a current we cannot escape. Far beyond the familiar stars of our own Milky Way, a colossal and invisible force is pulling us toward an unknown destination. Astronomers call this phenomenon the Great Attractor, a gravitational anomaly of such immense power that it is dragging our entire galaxy and countless others through the void at a staggering speed of over 2 million kilometers per hour. We are not floating aimlessly, we are falling. The unsettling truth is that we do not know what it is. This mysterious region of space lies in the so-called zone of avoidance, an area of the sky obscured by the dense gas and dust of our own galaxy's central bulge. It is like trying to see a mountain through a thick, perpetual fog. Our most powerful telescopes, from radio to X-ray, have only begun to pierce this cosmic veil, revealing a concentration of mass so vast it defies easy explanation. It could be a massive cluster of ancient galaxies or something even more exotic that we have not yet conceived. The sheer scale of this pull is humbling. Our local group of galaxies, a family that includes Andromeda and our own Milky Way, is caught in this relentless flow, all of us being drawn toward the same point in the darkness. This is not a gentle drift, it is a cosmic river with a current we cannot swim against. Where is it taking us? What awaits at the end of this journey? We are passengers on a galactic ship, sailing toward a shore we cannot see, pulled by a force whose nature remains one of the universe's most profound and terrifying secrets. That relentless pull toward the unknown is a journey with a final, chilling destination. Every story must have an end, and the universe itself is no exception. Its final chapter is not a fiery explosion, but a slow, cold whisper into an everlasting silence. This is the theory of the heat death of the universe, a fate dictated by a fundamental law of physics called entropy. Entropy is simply the natural progression of everything from order to disorder. Imagine a hot cup of coffee left on a table. It does not stay hot, it gradually cools until it is the same temperature as the room. The heat spreads out, dispersing evenly, and the system reaches a state of equilibrium where no further change can occur. The entire universe is following this exact same path. All the energy from all the stars, all the motion of galaxies, all the complex structures of life are slowly but surely spreading out and winding down. Billions of years from now, the last stars will exhaust their fuel and flicker out one by one. The galaxies will fade to black, leaving behind a scattering of dead stellar remnants, black holes, and frozen planets. Even these final monuments will not last. Over timescales so vast they defy human comprehension, black holes themselves will evaporate through a process known as Hawking radiation, slowly leaking their mass away until they too vanish into nothing. What remains is a universe that is utterly dark, cold, and still. The temperature will approach absolute zero, the point where all atomic motion ceases. With all energy evenly distributed across an infinite void, no work can be done, no stars can form, and no life can possibly exist. It is the ultimate and inescapable end of all things, an eternal, uniform graveyard where time itself loses all meaning. This is the final truth of our cosmos, a silence so complete and a darkness so profound that it makes every other terror we have faced seem fleeting by comparison. This cascade of destruction is a danger we are actively building with our own hands. The Kessler Syndrome is a self-perpetuating chain reaction waiting to be triggered in the orbital space above our heads. It begins with a single, catastrophic collision between two objects, perhaps a defunct satellite and a discarded rocket stage. The force of such an impact is so immense that it does not just destroy the two objects, it shatters them into thousands of smaller, high-velocity fragments. Each one of these new pieces becomes a hyper-fast bullet, now capable of causing its own destructive collisions with other satellites or debris. One impact creates a cloud of shrapnel, which then causes more impacts which create even more shrapnel. The process would feed on itself in an unstoppable domino effect until the entire band of low Earth orbit is transformed into a swirling maelstrom of metallic shreds traveling at tens of thousands of kilometers per hour. This is not a temporary problem. The incredible speeds mean that even a flake of paint can carry the destructive force of a hand grenade, capable of puncturing the hull of the International Space Station or a manned spacecraft. In a full-blown Kessler Syndrome event, any vessel attempting to leave our planet would be flying directly into a blizzard of shrapnel with almost no chance of survival. We would be sealing our own fate, constructing an impenetrable prison of our own technological waste. Our access to the final frontier would be severed for generations, perhaps centuries, until the slow drag of the upper atmosphere finally cleansed the orbit. The satellites that govern our modern world, from global communications and weather forecasting to GPS and financial networks, would be systematically pulverized, plunging our technologically dependent civilization into a new dark age. We are standing on the edge of creating a permanent barrier between humanity and the stars, a cage of our own making with the key just out of reach. Even as we build our own cage in orbit, a deeper, more profound silence echoes across the cosmos. The universe is unimaginably vast and ancient, with billions of planets that could cradle life, so where is everybody? This is the unsettling heart of the Fermi paradox, a question that transforms the empty night sky from a thing of beauty into a source of deep existential dread. The numbers are overwhelmingly in favor of alien civilizations. There are more potentially habitable worlds in our galaxy than there are grains of sand on every beach on Earth. With so many opportunities, the cosmos should be teeming with starships, alien megastructures, and radio signals, yet we hear nothing, we see nothing. The universe appears to be a ghost town. This profound silence is not peaceful, it is terrifying. It suggests that something is terribly wrong, that there is a barrier so great that no civilization can overcome it. This is the chilling concept of the Great Filter. The theory proposes that the evolution of life from its origins to a spacefaring civilization must pass through a series of incredibly difficult steps, and one of these steps is almost impossible to survive. Perhaps the filter is behind us, a fluke of abiogenesis so rare that we are truly the only ones in the entire galaxy. That is a lonely thought, but the more frightening possibility is that the Great Filter lies ahead of us. It could be that all intelligent life, upon reaching a certain level of technological maturity, inevitably discovers the means of its own destruction. This could be nuclear war, a runaway climate catastrophe, a genetically engineered plague, or an artificial intelligence that turns against its creators. Our own trajectory seems to be heading directly toward this very precipice. The silence of the universe, then, is not a sign of our solitude, but a graveyard of civilizations that came before us, each one snuffed out by its own hand. There is another, even more sinister solution to the paradox. What if the universe is not empty but full of predators? In a dark forest, a hunter stays silent to avoid revealing his position. This dark forest hypothesis suggests that every advanced civilization knows that to broadcast its existence is to invite annihilation from a more powerful and paranoid species. Any other life form is a potential threat to be eliminated before it becomes a competitor. In this terrifying scenario, the reason we have not made contact is because we are being deliberately ignored, or worse, quietly monitored until we become just interesting enough to warrant extermination. The silence is not empty, it is watchful. Are we alone because we are the first, the last, or simply the next to be culled? The answer to the Fermi paradox may be the most frightening discovery we could ever make. That profound silence might be the fate of all civilizations, but in the vast architecture of the cosmos, some places are born silent. Drifting in the constellation of Boötes lies a pocket of nothing so vast it defies human comprehension. The Boötes void is a spherical region of space, a staggering 330 million light-years across, that is almost completely empty. To put that impossible scale into perspective, if you placed our own Milky Way galaxy at the center of this void, the next nearest galaxy would be so far away it would be a lonely, barely visible speck in an ocean of black. This is not just a sparsely populated area, it is a cosmic desert of unprecedented size, containing only a few dozen galaxies where astronomers would expect to find thousands. The sheer scale of this emptiness is its own kind of terror. If our galaxy were located within the Boötes void instead of in our own relatively crowded galactic neighborhood, our night sky would be a canvas of almost pure black. The familiar, hazy band of the Milky Way would still arch overhead, but there would be no Andromeda galaxy to glimpse, no large or small Magellanic clouds. Every other island universe would be impossibly distant, far beyond the viewing power of the naked eye. For any civilization rising on a world within this void, astronomy would be a science of profound loneliness. They would look out and see only themselves, concluding that the universe was largely empty and that they were its sole, miraculous inhabitants. the true, chilling nature of the cosmos, teeming with billions of other galaxies, would remain forever hidden from them. They would be trapped in a prison of perfect isolation, adrift in a pocket of nothingness so immense that even the light from the closest galactic neighbors would take hundreds of millions of years to reach them. It is a permanent exile, a sentence of solitude on a cosmic scale, making the emptiness between stars feel crowded by comparison. This invisible architecture of nothingness is dwarfed by a far more pervasive mystery, a ghost in the very machinery of the cosmos. All the stars, galaxies, and cosmic voids we can see account for less than 5% of the universe. The rest is composed of two profound unknowns, and the dominant force is something we cannot see, touch, or directly detect: dark matter. This mysterious substance makes up roughly 27% of everything that exists. We know it is there only because of its gravitational pull. The galaxies in our universe are spinning so fast that the gravity from all their visible stars and gas is not nearly enough to hold them together. They should have flown apart eons ago. The only explanation is that each galaxy is embedded within a massive, invisible halo of dark matter, a gravitational scaffold that holds everything together with its unseen weight. It does not emit, absorb, or reflect any form of light, which is why our most powerful telescopes are utterly blind to it. The most unsettling part is that this shadowy material is not just out there in deep space. It is here, right now, flowing through the room you are in and passing directly through your body. Trillions of these elusive particles are streaming through you every second without a single interaction. You cannot feel it, and no instrument we have yet built can capture it directly. It is a constant phantom presence, a reminder that the solid reality we experience is an illusion. The very fabric of the universe is threaded with a substance we do not understand, a cosmic secret hiding in plain sight, its true nature one of the greatest enigmas of modern physics. Dark matter's ghostly presence is only half the story of our invisible universe. An even more dominant and mysterious force is at work, one that is not holding the cosmos together but actively tearing it apart. The universe is not simply expanding, this expansion is accelerating, driven by something we call dark energy. This enigmatic force makes up a staggering 68% of the entire cosmos, and we understand it even less than dark matter. Imagine a loaf of raisin bread baking in an oven. As the dough rises, every raisin moves away from every other raisin. This is the classic analogy for cosmic expansion. But with dark energy, it is as if the baker suddenly and violently started pumping more yeast into the dough, causing it to rise at a faster and faster rate forever. The raisins are not just drifting apart, they are being flung away from each other. This relentless acceleration has a terrifying long-term consequence for our view of the cosmos. As the space between galaxies stretches at an ever-increasing speed, there will come a time, billions of years from now, when the light from all other galaxies can no longer reach us. They will be receding so fast that their photons, racing across the universe at the speed of light, will be fighting a losing battle against the expansion of space itself. One by one, the galaxies will wink out of our sky, not because they have died, but because they have been pushed beyond the edge of our observable universe. The light from their stars will simply never be able to cross the growing chasm. Our Milky Way will be left utterly alone, a single, silent ship in an ever-growing sea of absolute darkness. For any future civilization that might arise on a world within our galaxy, the universe will appear to contain nothing but their own stellar family. All evidence of the grand billion-galaxy tapestry we see today will have vanished forever, lost behind an impenetrable curtain of expanding space. We are living in a uniquely privileged moment, a cosmic dawn where we can still see the evidence of our galactic neighbors, before the accelerating tide of dark energy carries them all away into eternal isolation. Our own star holds a power that could undo our world in a single, silent blast. While the sun provides the energy for all life on Earth, it also has a violent temper. The most dramatic expressions of this are coronal mass ejections, or CMEs. These are billion-ton clouds of superheated plasma and twisted magnetic fields that the sun can violently hurl into space at millions of kilometers per hour. Think of it as the star itself having a catastrophic sneeze, launching a wave of destruction across the solar system. Most of the time, these eruptions miss our planet entirely, or their weaker impacts are deflected by Earth's own magnetic shield, creating the beautiful auroras near the poles. But a direct hit from a truly massive CME is a different story altogether, a planetary-scale electromagnetic pulse. When such a storm of charged particles slams into our magnetosphere, it compresses and violently distorts the planet's magnetic field. This rapid motion generates incredibly powerful electrical currents in the ground itself and in any long, human-made conductor. Our entire global power grid, a vast and fragile network of wires and transformers, becomes the perfect receptor for this energy. The result would be a catastrophic overload. Massive transformers, the heart of any electrical grid, would heat up almost instantly and melt, exploding or burning out beyond repair. These are not small components you can replace overnight. They are custom-built, building-sized machines, and manufacturing a single one can take over a year. A severe enough solar storm would not just cause a temporary blackout. It would destroy the backbone of our power infrastructure, potentially frying thousands of these critical transformers across continents simultaneously. The lights would go out and they might not come back on for years. This is not science fiction. We have a chilling historical precedent. In 1859, a solar storm known as the Carrington event hit Earth. It was so powerful that telegraph systems, the advanced technology of the day, failed worldwide. Operators received severe shocks, telegraph paper caught fire, and auroras were seen as far south as the Caribbean. The event was a fascinating spectacle for a pre-electric world. If a storm of that magnitude, or one of the far larger ones we know the sun is capable of, were to strike today, the consequences would be apocalyptic. With a grid destroyed, society would begin to unravel within days. Without electricity, water treatment and distribution would halt. Refrigeration would stop, leading to food spoilage and mass starvation. Heating and air conditioning would fail, hospital backup generators would run out of fuel, banking and financial systems would collapse as digital records vanished. Global positioning systems and communication satellites would be fried, severing our global nervous system. We would be thrust back into a pre-industrial age almost overnight, but with a global population of billions utterly unprepared to survive in it. The terrifying truth is that such an event is not a matter of if, but when. Our sun is a constant reminder that our technological civilization is built on a foundation of sand, vulnerable to the next tantrum from the star that gives us life. These beautiful clouds of cosmic dust and gas, immortalized in breathtaking telescope images, are not the serene landscapes they appear to be. The iconic pillars of creation, for instance, are a stellar nursery located 7,000 light-years away, colossal towers of cool gas and dust where new stars are constantly being born. Yet this nursery is a place of unimaginable violence. The very stars being born within and around these pillars are also the agents of their destruction. The most massive of these infant stars burn incredibly hot and bright, emitting torrents of intense ultraviolet radiation and powerful stellar winds. This radiation is so energetic that it literally boils the gas off the pillars, slowly eroding them away into the void, while the stellar winds act like a cosmic sandblaster, sculpting and tearing apart the structures from which they themselves formed. This creates a paradox of creation and destruction happening simultaneously. For any potential planetary systems trying to coalesce within this beautiful chaos, the environment is utterly hostile. The same forces that trigger the collapse of gas clouds to form stars can also shred the surrounding protoplanetary disks. the swirling rings of dust and debris that are the raw material for new worlds. A young planetesimal on the verge of becoming a full-fledged world could have its fragile atmosphere stripped away or be blasted apart entirely by a nearby stellar eruption. The birth of a star system is not a gentle, protected process, but a gauntlet of radiation and gravitational turmoil. These nebulae are cosmic crucibles as deadly as they are beautiful, proving that from our very first moments, the universe is a trial by fire. Dark energy is the universe's greatest unsolved mystery, a phantom force that makes up nearly 70% of everything. It is the reason the cosmos is not just growing, but flying apart at an ever-increasing speed. Think of the expansion of the universe like a car rolling slowly down a hill. You would expect gravity, the pull of all the matter in the cosmos, to act like brakes, gradually slowing that car down. Instead, astronomers discovered the car is accelerating, as if someone had pressed an invisible pedal to the floor. That someone is dark energy. Its effect is a form of repulsive gravity, a push instead of a pull, working against the attractive force of dark matter and everything we can see. This is not a gentle nudge, it is a relentless pressure embedded in the fabric of space itself, stretching the void between galaxies wider with every passing moment. The true nature of this force is completely unknown. It could be a property of empty space, a constant energy field that grows stronger as the universe expands. Or it could be evidence of a fifth fundamental force of nature, one that we have not yet begun to comprehend. Whatever it is, its power is absolute. This invisible, undetectable energy is single-handedly dictating the final fate of everything we will ever know. It is the ultimate puppet master, and we are only just beginning to see the strings. The universe we know is built upon a foundation that might be fundamentally unstable. This is the terrifying hypothesis of the false vacuum, a concept that suggests our entire cosmos is resting in a precarious state, like a ball sitting in a small dip on the side of a vast, steep hill. In this analogy, the ball represents the fields and energies that define our reality. Our current laws of physics, the constants that allow atoms to form and stars to shine, exist only because the ball is temporarily settled in this shallow valley. But this is a false valley, a metastable state. The true, lowest energy state, the real bottom of the hill, lies far below. All it would take is a single, random quantum event anywhere in the universe to nudge the ball over the edge. If that happened, a bubble of this true vacuum would spontaneously form. The laws of physics inside this bubble would be completely different and utterly hostile to the existence of matter as we know it. Atoms would instantly disintegrate, molecules would cease to hold together, and the very fabric of space-time would be rewritten. This bubble would then expand in all directions at the speed of light, a wall of fundamental annihilation. The most horrifying part is that there would be no warning. You could not see it coming because the wave of destruction travels at the ultimate speed limit. One moment, the universe would exist as it always has. The next, an invisible sphere of nothingness would be upon you, and in an instant, everything you have ever known would simply cease to be, erased from existence without a trace. This cosmic reset button could be pressed at any moment in a galaxy far, far away, and we would be blissfully unaware until the final, instantaneous blink of reality. This constant, invisible danger from the cosmos is matched by a more tangible and familiar threat, one that has already reshaped our world. The solar system is a shooting gallery, and Earth is the largest target. Our planet is constantly being bombarded by debris left over from its formation, a swarm of asteroids and comets known as near-Earth objects. The numbers are staggering. Astronomers have catalogued over 30,000 of these objects, with thousands more discovered every year. Each one is a potential weapon, a rock traveling at tens of thousands of kilometers per hour. The smallest ones burn up as harmless meteors in our atmosphere, but it is the ones we do not see that pose the real danger. For every asteroid we have tracked and mapped, there are countless more lurking in the darkness, their orbits unknown and their trajectories a mystery until it is too late. We have a chilling history of what happens when a large one finds its mark. 66 million years ago, an asteroid estimated to be 10 kilometers wide slammed into what is now the Yucatan Peninsula. The impact released energy billions of times greater than the atomic bomb dropped on Hiroshima. It triggered global firestorms, mega tsunamis, and a shroud of dust and ash that blotted out the sun for years, leading to the extinction of the dinosaurs and 75% of all life on Earth. That event was not a fluke, it was a demonstration of a fundamental rule of our solar system. Large impacts are not a question of if, but when. Statistically, a city-killing asteroid, one large enough to wipe out a metropolitan area, strikes our planet on average once every century. We were reminded of this in 1913, when a relatively small object exploded over Tunguska, Siberia, flattening 2,000 square kilometers of forest. Had it arrived just a few hours later, it could have obliterated a major European city. Our current detection systems are a vast improvement, but they are far from perfect. We are still vulnerable to asteroids that approach from the direction of the sun, hidden in its glare, or those composed of dark, non-reflective rock that are nearly impossible to spot until they are alarmingly close. While plans for asteroid deflection exist, from kinetic impactors to gravity tractors, none have been fully tested on a real threat. We are playing a cosmic game of dodgeball, and we are only just beginning to see the balls being thrown. The next world-altering impact is already out there, drifting in the void, and our name could be on it. Our fragile existence on Earth is cradled in a narrow band of comfortable temperatures, a fleeting oasis in a cosmos ruled by brutal extremes. Space itself is a canvas of unbearable heat and cold, a vacuum that offers no moderation. In the direct glare of a star, temperatures can soar to hundreds of degrees Celsius, hot enough to boil metal and fry electronics in an instant. Yet, step into the shadow, into the deep void between stars, and the temperature plummets to near absolute zero, that theoretical point where all atomic motion ceases. For an unprotected human, these swings are a death sentence in 2 acts. On the sunlit side of an object, your body would be seared by intense radiation, your skin burning in an environment with no air to carry the heat away. On the shadowed side, you would flash freeze, the scant heat within your body radiating out into the infinite cold in a matter of seconds. This is not a slow process of getting chilly. It is an instantaneous leaching of all warmth, leaving you a frozen statue. Surviving this requires technology of incredible resilience. Spacecraft are meticulously engineered to withstand this relentless assault. They are swathed in reflective, white blankets of multi-layer insulation to deflect solar radiation, and equipped with intricate heating systems and radiators to carefully manage internal temperatures. Every mission is a high-wire act, a constant battle against an environment that is perpetually trying to either incinerate or deep freeze anything we send into it. The void is not empty, it is actively hostile, enforcing its rule through fire and ice. The universe has one final, deeply personal trick to play on any traveler who dares to cross its vast distances. Time itself is not the constant river we believe it to be. According to Einstein's theory of relativity, time is a flexible dimension warped by speed and gravity. This phenomenon is called time dilation, and its consequences are both mind-bending and terrifying. The faster you move through space, the slower time passes for you relative to someone who is stationary. The same effect occurs in a powerful gravitational field, like that near a black hole, where time crawls compared to a region of weaker gravity. For an astronaut on a hypothetical journey to a nearby star at a significant fraction of the speed of light, this is not a minor physics curiosity. It is a one-way ticket to the future. While the astronaut might experience a voyage lasting only 10 years from their perspective, due to the effects of their incredible speed, decades or even centuries could have passed back on Earth. Imagine the horror of returning home after what felt like a manageable mission, only to find your world utterly transformed. Everyone you ever knew, your entire family and friends, would have grown old and died generations ago. You would be a living fossil, a relic from a bygone era stranded in a future you do not recognize. Your very presence would be a paradox, a human being younger than their own great-great-grandchildren. This is the ultimate isolation, a loneliness enforced not by space but by time itself. The universe offers the stars, but the price of reaching them may be everything you have ever loved. This ancient echo is the closest we can come to hearing the birth of the universe. Known as the cosmic microwave background, it is the faint, cold glow that fills every cubic centimeter of the cosmos, a ghostly afterglow from the very first light. To understand its origin, you must travel back nearly 14 billion years to a moment of impossible density and heat, the Big Bang. In its immediate aftermath, the universe was a searing, opaque plasma, a thick soup of energy and fundamental particles where light could not travel freely. It was trapped, constantly bouncing and scattering. After about 380,000 years, the expanding universe had cooled just enough for atoms to form, allowing light to finally break free and stream across the void. That first brilliant flash of liberation has been traveling ever since. But as the universe continued to expand and cool, that primordial light stretched along with the fabric of space itself. Its wavelengths were pulled and elongated, shifting from visible light down through the spectrum into microwave radiation. Today, this radiation has cooled to a mere 2.7 degrees above absolute zero, a frigid whisper that permeates the entire universe. If you could see microwave light, the entire sky would glow with a uniform, faint light, a perfect canvas of creation. This is not a distant signal from one point in the sky. It is all around us, a fossilized echo from the moment the universe became transparent. It is the oldest thing we can possibly observe, the residual heat from the cosmic fireball that gave birth to everything. Every time you see static on an old analog television, about 1% of that chaotic snow is this ancient relic, the literal afterglow of creation interfering with your broadcast. We are all bathed in this primordial energy, a constant, silent reminder that our entire reality was born from a cataclysmic event of unimaginable violence, and its faint, cold breath still touches everything. That ancient echo of creation is a whisper compared to the universe's most violent screams. Quasars are the brilliant, furious hearts of the most distant galaxies, cosmic beacons so luminous they can outshine an entire galaxy of 100 billion stars. Yet this incredible light is not the glow of creation, but the death rattle of matter on an unimaginable scale. At the center of every quasar lies a supermassive black hole, a monster with the mass of millions or even billions of suns. As vast clouds of gas, dust, and even entire stars are pulled into its gravitational clutches, they do not simply vanish. This doomed material forms a searingly hot, flattened disk of plasma, spinning at nearly the speed of light as it spirals inward. The friction and magnetic forces within this accretion disk heat it to temperatures of millions of degrees, causing it to blaze with the light of a trillion suns. But the true engine of destruction lies in the black hole's poles. From these points, the quasar focuses this unimaginable energy into two narrow, opposing beams of radiation and charged particles, firing across intergalactic space like a cosmic blowtorch. If one of these beams were to be pointed directly at our solar system, the consequences would be absolute. From thousands of light years away, it would appear as the brightest object in our sky, a second malevolent sun. The beam would deliver a constant, sterilizing dose of high-energy radiation, powerful enough to strip away our planet's atmosphere and scramble the DNA of every living organism on the surface. The ozone layer would be obliterated in an instant, allowing the full, unfiltered fury of our own sun's ultraviolet light to scorch the planet. Earth would be cooked, its biosphere erased down to the last microbe. We are fortunate that the nearest known quasar is hundreds of millions of light years away, its deadly beam aimed in some other unlucky direction. But their existence serves as a stark reminder that the centers of galaxies are not peaceful places. They are the sites of cosmic warfare, where gravity unleashes forces that can snuff out life across interstellar distances. That same thin blue line is all that shields us from the void. Our atmosphere, the very air we breathe, is far more fragile than we dare to believe. From the surface, the sky seems endless and vast, an infinite blue expanse. But from space, the truth is laid bare. The life-giving blanket of gas that envelops our world is an astonishingly thin film, a delicate veil clinging to the surface of a tiny marble. If the Earth were the size of a standard classroom globe, the entire atmosphere, every single layer from the ground to the edge of space, would be about as thick as 2 coats of paint. This minuscule shell is responsible for everything. It protects us from the sun's most harmful radiation. It burns up the vast majority of incoming space debris, and it regulates our climate to within a narrow, life-sustaining range. Yet this entire system is incredibly vulnerable. A single, large volcanic eruption can hurl enough ash and sulfur dioxide into the stratosphere to temporarily cool the planet. A massive asteroid impact, like the one that doomed the dinosaurs, can fill the sky with so much dust and soot that it triggers a global winter, collapsing food chains worldwide. Even our own technology poses a grave threat. A full-scale nuclear war would not only cause immediate devastation, but the resulting firestorms would inject vast amounts of black carbon high into the atmosphere, blotting out the sun for years and causing a catastrophic nuclear winter that would starve billions. Our atmosphere is not a permanent, immutable fortress. It is a temporary, dynamic, and exquisitely balanced bubble. The iconic pale blue dot photograph, taken by the Voyager 1 spacecraft from the edge of our solar system, captures this profound vulnerability. In that image, Earth is a mere speck of light, a single pixel suspended in a sunbeam. Every human being who has ever lived, every triumph and tragedy, every forest and ocean, exists on that tiny, pale blue dot, wrapped in its impossibly thin and precious coat of air. All of our history has unfolded within that fragile layer. Its preservation is the single most important task for our species, for without it, the blue dot fades to just another dead rock in the chilling, airless dark. Flashes of cosmic static can carry more power than our sun emits in 80 years. Fast radio bursts are one of the most perplexing phenomena in the universe, intense blasts of radio waves that travel for billions of years across intergalactic space only to vanish in the blink of an eye. Lasting just a few thousandths of a second, these bursts pack an almost unimaginable amount of energy into a fleeting, invisible flash. Their origins are a complete mystery, sparking debates that range from the cataclysmic to the deeply unsettling. The most conventional explanation points to the violent deaths of stellar objects. A magnetar, a type of neutron star with an unimaginably powerful magnetic field, could be the culprit. The star's crust, under immense strain, might suddenly crack, releasing a titanic shockwave of energy in a brilliant radio flash. Alternatively, the collision of 2 ultra-dense neutron stars could produce a similar one-time signal. But then there are the repeaters. Some sources of these bursts have been observed firing off multiple signals, not just a single, final cataclysm. This repetitive nature shatters the simple explanation of a one-time collision or explosion. What natural process could cause such a powerful event to happen over and over again? This is where the theories venture into truly uncharted territory. Could these bursts be the result of something we have not yet conceived, a new type of astrophysical object or a process that defies our current understanding of physics? Or, in the silence of the Fermi paradox, does a more unnerving possibility whisper in the data? some scientists have cautiously speculated that such focused, energetic transmissions could be evidence of advanced technology. A civilization capable of engineering on a stellar scale might use incredibly powerful bursts to propel light sails on interstellar voyages, their ships pushed across the galaxy by these focused pulses of energy. Each flash we detect could be the ignition of a distant engine, a signature of someone else's journey. Another theory suggests they could be leakage from a beacon, a purposeful signal so powerful it briefly outshines entire galaxies. The terrifying implication is not that they are trying to talk to us, but that we are simply overhearing a technology so vast and powerful its background radiation is a cosmic siren. We are left staring at these milliseconds of data, wondering if we are witnessing natural stellar death throes or the faint, unintentional signature of an intelligence so advanced its very machinery mimics the violence of the cosmos itself. Our bodies are exquisitely tuned for a life of gravity, a constant pull we have evolved with for millions of years. Remove that fundamental force and the human form begins to unravel in terrifying ways. The condition known as microgravity is a physiological lie, convincing your body that it is floating in a perpetual state of freefall. Without the need to stand against gravity, your muscles begin to waste away at an alarming rate. Astronauts can lose up to 20% of their muscle mass on a single 5-month mission, their legs becoming weaker and their back muscles deteriorating, leaving them struggling to walk upon their return to Earth. But the decay goes far deeper than muscle. Your very skeleton, the framework that holds you up, starts to dissolve. In the absence of weight-bearing stress, the body's careful balance of bone construction and demolition is shattered. Bone-eating cells become hyperactive while bone-forming cells slow to a crawl. The result is a catastrophic loss of bone density, as much as 1 to 2% per month in critical areas like the hips and spine. An astronaut on a year-long mission could return with the skeletal structure of an elderly person with severe osteoporosis, their bones brittle and prone to fracture. This is not a temporary ache, it is a fundamental rewriting of your biology. The fluid distribution in your body is also thrown into chaos. On Earth, gravity pulls your bodily fluids down into your legs. In space, that fluid redistributes evenly, rushing upward into your torso and head. Astronauts often experience puffy faces and congested sinuses, a condition sometimes jokingly called bird legs due to the thinning of their lower limbs. But the effect on vision is no joke. This intracranial pressure can flatten the back of the eyeball and damage the optic nerve, leading to long-lasting and sometimes permanent impaired vision for many space travelers. Perhaps most insidious of all is the quiet assault on your immune system. The stress of spaceflight combined with the strange environment seems to confuse your body's defenses. Your immune cells become less effective, almost lethargic, while latent viruses like chickenpox, which hide in your nerve cells, can reactivate without warning. You become more vulnerable to infections, and your body's ability to fight even a common cold is dramatically weakened. These are not separate issues, but interconnected symptoms of a body profoundly lost. The dream of long-term spaceflight to Mars or beyond is a dream of humans who would arrive at their destination as fragile, weakened shells, their bodies fundamentally altered by the journey itself. We are creatures of Earth, and the price of leaving our world may be paid in the slow, systematic dismantling of our own flesh and bone. This man-made ring of garbage is a permanent monument to our carelessness. Every deactivated satellite, every discarded rocket stage, and every fragment from an accidental collision remains in orbit, trapped in a high-speed ballet around our planet. These objects do not simply float, they race at velocities exceeding 17,000 miles per hour, a speed where momentum becomes absolute. At such velocity, the energy packed into even the smallest object is terrifying. A fleck of paint no larger than a grain of sand carries the destructive force of a bowling ball dropped from a multi-story building. A metal screw becomes an armor-piercing round, capable of punching straight through the critical systems of a spacecraft or satellite. This is not a hypothetical danger. The International Space Station regularly performs maneuvers to dodge tracked debris, a constant reminder that our greatest outpost in space exists within a shooting gallery of our own creation. The true terror lies in the permanence of this pollution. In the vacuum of space, there is no air resistance to slowly drag this junk down to burn up in the atmosphere. Depending on their altitude, these fragments can remain in orbit for decades, centuries, or even millennia. We have surrounded our world with a shell of shrapnel that will outlive our civilizations, a razor-wire fence that future generations must learn to navigate. Every new launch, every new satellite we add to the constellations above, risks adding another piece to this cascading puzzle of destruction, pushing us closer to the point of no return where a single collision could trigger the runaway chain reaction of the Kessler Syndrome. We are sowing an orbital minefield, and the key to disarming it is rapidly slipping from our grasp. Our galaxy is a minefield of sleeping giants, each one a potential doomsday device. A supernova is the final, cataclysmic death of a massive star, an explosion so brilliant it can momentarily outshine its entire host galaxy. This is not a gentle fading, but a stellar heart being torn apart in a shockwave of unimaginable violence. If such an event were to occur within a few dozen light-years of Earth, the consequences would be an extinction-level event. The first sign would be a new star in the sky, impossibly bright, visible even during the day. But that light would be the least of our worries. Following close behind would be a flood of high-energy cosmic rays and gamma radiation, a lethal wave that would strike our planet with the force of 1 billion nuclear bombs detonating at once. This radiation would not be blocked by our atmosphere, it would shred it. The ozone layer, our primary shield against the sun's ultraviolet rays, would be chemically destroyed on a global scale. With that protective blanket gone, the surface of the Earth would be bathed in a sterilizing ultraviolet light, devastating the base of the food chain by killing off plankton in the oceans and plant life on land. The sky would turn a hazy, chemical brown, and the climate would spiral into a deep freeze, triggering a long, dark winter that would starve any larger life forms that survived the initial radiation blast. The terrifying truth is that our galactic neighborhood is home to several ticking time bombs, massive stars like Betelgeuse in the constellation of Orion. These red supergiants are cosmic corpses in waiting, destined to end their lives in a supernova explosion at any moment, astronomically speaking. Their final moments could come in 1,000 years, or it could happen tonight. The light from such an event would already be on its way, and there is absolutely nothing we could do to stop it. We live in the calm between stellar storms, a fragile peace maintained only by the vast distances between the stars. But those distances are not infinite, and the universe is always one violent flash away from reminding us just how small and temporary our place in it truly is. The crushing emptiness of space inflicts a deep and silent wound on the human mind. Beyond the physical deterioration, astronauts face a profound psychological battle against an environment of absolute isolation and confinement. They are sealed inside a tiny, fragile capsule for months or even years, separated from every comfort of Earth by an infinite, airless void. The constant, low hum of machinery becomes the only sound, a monotonous reminder of their total dependence on failing technology. They cannot feel the wind, smell rain, or touch another living thing not brought with them. This sensory deprivation, combined with the knowledge that rescue is impossible, can breed a unique form of claustrophobic terror, a feeling of being buried alive in a metal coffin hurtling through a graveyard. But an even more profound shock awaits those who look back at our world. From their unique vantage point, astronauts often experience the overview effect, a cognitive shift in awareness. They see Earth not as a vast, endless world of separate nations and conflicts, but as a single, breathtakingly beautiful and heartbreakingly fragile blue marble hanging in the utter blackness. There are no borders visible from space, only a thin, glowing atmosphere that seems no thicker than a soap bubble. This realization is not always one of peace and unity. It can be a source of existential dread. The planet that contains everyone and everything you have ever known is reduced to a tiny, insignificant speck, a lonely oasis in a cosmic desert of unimaginable scale. All of human history, every war, every achievement, every love story has occurred on that solitary pixel of light. This perspective can induce a crushing sense of insignificance, a terrifying anxiety that our struggles are meaningless in the face of such infinite emptiness. The very thing that promises a new perspective on our world can also deliver the chilling message that our world does not matter at all. 13.8 billion years stretches across a timeline so vast it crushes human comprehension. We mark our own history in centuries, our civilizations in millennia, but the universe operates on a scale where 1,000,000 years is a fleeting moment. If we compressed the entire cosmic story into a single calendar year, with the Big Bang at the stroke of midnight on January 1st, our modern human species would not appear until the final few seconds of December 31st. Every empire we have ever built, every war fought, every work of art created, all of it occupies less than a heartbeat on this cosmic clock. This immense age is not just a number, it is a profound and terrifying emptiness. Within those billions of years, there has been more than enough time for countless other civilizations to have risen, flourished, and vanished into eternal silence. Entire empires of beings with their own histories and dreams could have lived and died in the dark, their worlds now cold and their stories lost forever. We search the skies for signs of others, but we are like someone walking through a desert long after a great festival has ended, finding only scattered, untraceable footprints in the sand. The silence we hear is not the silence of an empty house, but of a house whose previous occupants left eons ago. Our entire existence is a flicker in a darkness that has lasted for ages and will continue for ages more. We are not just small in space, but heartbreakingly brief in time, a single, fragile note played in an endless, silent symphony. Our solar system feels like a permanent, stable family of planets, but its infancy was a chaotic gravitational free-for-all. In the early days, dozens of young planets swarmed around the Sun, their orbits unstable and overlapping. As these massive bodies jostled for position, they engaged in a cosmic game of gravitational pinball. A close encounter between two planets could easily transfer enough energy to send one of them hurtling away from the Sun's grasp forever. This planet would be ejected from its solar system entirely, cast out into the frigid, lightless expanse of interstellar space. These are the rogue planets, frozen worlds condemned to an eternity of wandering the galaxy alone. They are not bound to any star, with no sunrises, no seasons, and no source of external warmth. Their surfaces would be layers of solid ice over a potentially frozen core, a permanent winter under a sky devoid of any other celestial bodies, just the unblinking, distant stars. The terrifying thought is that Earth itself could have been one of these castaways. During the solar system's violent youth, a slightly different gravitational nudge could have sent our own world spiraling into the darkness. Instead of the vibrant, life-filled planet we know, Earth would have become just another frozen marble tumbling through the void, its potential for life forever locked in ice. Astronomers now believe these lonely exiles vastly outnumber the stars in our galaxy, a hidden population of billions of dark, silent worlds, each one a monument to a gravitational near-miss and a chilling reminder of how easily our own home could have been lost to the cold. Our own senses are a prison, trapping us in a world of illusions. We see a rainbow of colors, but our eyes capture less than 1% of the full electromagnetic spectrum. We hear the wind and the rain, but our ears are deaf to the gravitational waves that ripple through the cosmos. The reality we experience is a narrow, curated sliver of what truly exists, filtered through biological receptors that evolved for survival on Earth, not for comprehending the universe. We have built machines to extend our perception, revealing X-rays and radio waves, but even our greatest instruments are blind to the universe's dominant components. Dark matter and dark energy, the twin phantoms that make up 95% of everything, remain completely invisible and undetectable to us. They are the ultimate hidden reality, a cosmic play unfolding in a theater we cannot see. The human brain itself, a 3-pound organ of wet tissue, may be the ultimate limitation. It evolved to recognize patterns, avoid predators, and find food, not to intuitively grasp 11-dimensional space or the quantum entanglement of particles. Our very logic and mathematics might be nothing more than a useful tool for navigating our tiny corner of existence, utterly incapable of describing the deeper, stranger truths of the cosmos. We are like ants trying to understand the internet, our minds simply not equipped with the necessary framework. Perhaps the most terrifying truth of all is that the ultimate nature of reality might be forever and fundamentally unknowable to us. We are trapped behind a veil of our own making, staring at shadows on a cave wall, forever wondering what is casting them. This deep, cosmic silence returns us to our most profound and terrifying question. We have scanned the heavens for decades, listening for any whisper of another voice in the void, and we have heard nothing but the natural static of the universe. The Fermi paradox asks why, in a galaxy that should be buzzing with life, we are met with such an absolute and unnerving quiet. There are 3 deeply unsettling answers to this mystery, and each one carries its own unique form of dread. The first possibility is that we are truly cosmically alone. The chain of events that led from non-living chemistry to a self-aware civilization capable of looking up at the stars might be so astronomically rare that it has only happened once. In this scenario, the entire vast galaxy, with its hundreds of billions of stars, is our inheritance, a silent empire waiting in the dark. But this is a lonely and chilling crown to wear, for it means that every beautiful sunset, every feeling of love, and every great work of art exists only here on this tiny world. There is no one else to share it with, no one to learn from, and no one to carry the torch of consciousness if we fail. The second possibility is that intelligent life is not rare, but it is tragically fragile. Perhaps the great filter, that barrier which prevents life from reaching the stars, is not behind us but ahead of us. It could be that every civilization, upon reaching a certain level of technological maturity, inevitably discovers the means of its own destruction. This could be nuclear war, a genetically engineered plague, a climate catastrophe of their own making, or an artificial intelligence that turns against its creators. In this view, the silence of the universe is not a sign of our solitude, but a graveyard of civilizations that came before us, each one snuffed out by its own hand. We could simply be the next in line, racing toward that same precipice. The third, and perhaps most terrifying, answer is that the universe is not empty at all, but full of predators. In a dark forest, a hunter who makes a sound reveals his position and is quickly eliminated. The dark forest hypothesis suggests that every advanced civilization knows this fundamental rule of cosmic survival. To broadcast your existence is to invite annihilation from a more powerful, paranoid, or simply ruthless species. Any other life is a potential competitor for resources, a future threat that must be eliminated before it can grow. In this scenario, the reason we have not made contact is not because they are not there, but because they are hiding, watching, and waiting. Our own radio and television signals have been leaking into space for over a century, a bright beacon in the cosmic dark announcing that we are here, we are alive, and we are naive. So the profound silence we hear is not empty, it is watchful. It is the quiet of a forest where every other creature is holding its breath, afraid to make a sound. Are we alone because we are the first, the last, or simply the next to be culled? The answer to the Fermi paradox may be the most frightening discovery we could ever make. From the silent, airless death of the vacuum to the ultimate cold whisper of heat death, our journey through the cosmos reveals a universe of breathtaking beauty and profound terror. We have faced the phantom menace of rogue black holes and the instantaneous annihilation of gamma-ray bursts. We are pulled by the unseen hand of the Great Attractor and threatened by the prison of our own orbital debris. The sun that gives us life holds the power to erase our civilization with a single blast, while the silent, empty sky speaks to the eerie possibilities of the Fermi paradox. We have wandered through the cosmic desert of the Boötes void and learned that the very fabric of reality is woven from the invisible threads of dark matter and dark energy, forces that will one day isolate our galaxy in eternal, expanding darkness. We have seen that our own biology betrays us in microgravity, that our atmosphere is a fragile coat of paint on a global canvas, and that our solar system's past was a violent game of planetary pinball that could have easily cast our world into the frozen abyss. We are living on borrowed time in a cosmic shooting gallery, surrounded by the ticking time bombs of supernova and the ever-present threat of impacts from the dark. The universe is a place of violent extremes, from the crushing gravity of neutron stars to the phantom signals of fast radio bursts whose origins could be natural cataclysms or the engines of civilizations far beyond our own. The very laws of physics may be resting on a precarious false vacuum, and our own perception is a prison, limiting our understanding of a reality that may be forever unknowable. These 30 facts are not meant to paralyze us with fear, but to awaken a new, more profound respect. They teach us that space is not a serene postcard, but a dynamic and often hostile frontier. Let this knowledge change how you see the pale blue dot we call home. See it for what it truly is, a miraculous and fragile oasis in an infinite, chilling void. The next time you look up at the stars, do so with a sense of awe, but also with a sober understanding of the dangers that lurk in that magnificent darkness. We would love to hear which of these cosmic truths unsettled you the most. Share your own most frightening space fact in the comments below and continue the exploration together.